Hello again, algebra lovers. I hope you are, because that's what we're going to do right now. We're going to take a look at, actually, I decided to do a video, two videos actually, on partial fraction decomposition, how to break apart a rational expression into the sum difference of smaller fractions with simpler denominators. We do it in our class because we need to integrate. So if we can break it apart, then it's integrable, we're in good shape. Okay, so the way this works is, I'll just go through the steps with you. Let's do this color today. What you're going to do is go ahead and factor the denominator. You remember how to factor, don't you? So we have x minus 2 and x plus 1 if I'm not, yeah, that works pretty well for me. Now here's the thing. Those are the two factors in the denominator. Guess what? We're going to pretend that someone took one of each, a fraction with each denominator, and added them together somehow, okay? So when I split this apart, this is what we do next, is we write one denominator here plus another denominator here, and what goes above the first degree x polynomial in the denominator, okay, is going to be a polynomial of one lesser degree, because otherwise you can long divide it, it's a mess. No, all you have to do is, and I'll do this in red, is put up here mystery numbers, okay? All right, that's the essence of it. We're going to find the A and the B that makes this thing true. And if we can, then later in another video, we're going to be able to integrate this thing, okay? All right, so, right, let's write what we've got. We've got x minus 5 over, and I'll write it in factored form, x minus 2, x plus 1, can be torn apart, so to speak, into two fractions that add up to that guy. Okay, so our first move, and I have to really explain this from experience, I know, I have to do this, so if you want to fast forward, that's fine, but if not, you can pause and survey the terrain. What we do is we multiply both sides. We're going to clear fractions and compare the resulting expression. So this is really the move. You don't have to write all this because it becomes very mentally quick and easy to do, because what happens next is that these guys cancel and you're left with x minus 5 on the left. This is algebra. All of what we're doing is algebra, right? And then when you distribute here, when it hits the first fraction, you lose the x minus 2, but you're left with a times x plus 1. And likewise, you're going to lose the x plus 1 and b times x minus 2. And here we are. So for a and b to make sense in the top equation up here, a and b have to make sense in this equation upon clearing fractions. Okay? For them to make sense then, I'm going to distribute the a. Now at this point, there's another way to do it, and I'll backtrack in a little while and show you there's an easier way to do it. But right now, we need to have a foundation for what we're doing. I'm going to distribute those guys, and we're going to get ax plus a plus bx minus 2b, and here we are, okay? This is another big step, because finally what we're going to do is we're going to say the x terms here, here, and here on either side have to match for a and b to work. They have to match. So what that means is that, you know what? What it means is that, I'll write it out, a plus b on the right-hand side has to equal 1 on the left-hand side. See, ax plus bx has to equal 1x. So a and b added together have to make 1. I don't care how you do it, but that's what has to happen, okay? Likewise, pause it then and stare. Does that make sense? The minus 5 constant has to be made by adding these guys together, okay? So what does that say? Well, I'll write it underneath here. It says that a minus 2b has to equal minus 5. And what have we got here? We have a system to solve. We have a system to solve. So, I mean, if you want me to do it, I will. I think you might know how to solve systems, but what I would probably do here is double up the top equation And what I'm doing is I'm going back to algebra 1, you know, and solving a system. So what I have is 2a and a make 3a, and the 2b minus 2b disappears, and I have 2 minus 5 is minus 3, and we realize, oh, then a is -1, and we found one of the numbers, and that's a big deal, okay? Then if you know that, you also know that a plus b is 1 from the top equation, so -1 plus b is equal to 1, and you realize that b is equal to 2, and you have done it. What that means is you can rewrite this guy. You can tell the world, you know what, x minus 5 all over x squared minus x minus 2 can be written as a, see it up there, over x minus 2. So what is a? It's -1, so -1 over x minus 2, and b is 2 over x plus 1, so plus 2 over x plus 1. And you did it. We decomposed the fraction into the sum of smaller fractions. Okay, now, I said there was an easier way. So that's where you can pause the video and rewind if you want, but x minus 5 is equal to a x plus 1 and then plus b, and you're going to probably find you can do this part mentally, a lot of you. You just simply go, okay, it has to work. This has to be true. A and B have to satisfy this for every x. And you know what? Standing on the shoulders of the giants of the past, they're clever. They went, well, look at this guy. Hey, what if x is -1? What happens then? You let x equal -1. If you do, you have on the left -1 minus 5 is equal to a -1 plus 1. The reason that's good is goodbye. And then plus b -1 minus 2. And you end up with -6 is equal to -3b. And lo and behold, b is equal to 2, which is correct. Okay, isn't that clever? And then if you want to go let x equal the other guy, why don't we make it 2, right? That makes sense. Then we have 2 minus 5 is equal to a 2 plus 1 plus b 2 minus 2, bye-bye. And we've got -3 is equal to 3a, and lo and behold, boom, a is equal to -1. And yeah, so that's really what I wanted to show you. Gain confidence in this section. Most of the work is partial fraction decomposition of these things. I'll do another one, and this time it'll have an irreducible quadratic. All right, you guys, see you in the next one. It's just so fun.